Let's talk about probabilities where they have to do with complementary events. So the complement of an event A, which in this book is denoted by A with a line over the top, consists of all outcomes in which the event A does not occur. So the complement of A includes all the outcomes in the sample space that are not outcomes in the event A. That means A and A complement together make up the whole sample space. Here we have a picture. This is the whole sample space inside of this box. This in the circle is the event A, so everything outside of the circle is the complement of A. So if we put those two together, A and A complement, they give us the whole sample space. An example of complementary events is that a typical question on an SAT test requires the test taker to select one of 5 possible choices, A, B, C, D, or E. Because only one answer is correct, if you make a random guess, your probability of guessing correctly is 1/5 or 0.2. If we want to find the probability of guessing incorrectly is the complement of the event of guessing correctly. So incorrect is the complement of correct. Now, exactly one of the 5 choices is correct. That means that 4 of the choices are incorrect. So the probability of guessing incorrectly is 4/5 because we had 4 incorrect choices out of the 5 total. That means the probability of guessing incorrectly is 4/5, or if as a percentage, it would be 80%. So if we're talking about probabilities for complementary events, we need to think about the relationship between A and its complement. A and A complement are disjoint. That means they don't have anything in common. So it's impossible for an event and its complement to occur at the same time. That gives us a rule to figure out the probability for complementary events. If A and A complement are disjoint, and if together they make up the whole sample space, then the 2 probabilities added together should equal 1, because we've got 100% of the outcomes in the sample space if we put the 2 events together. So our first rule is that the probability of A plus the probability of A complement is equal to 1. From that, we can get 2 other rules, and this is usually how we use this rule. So if we're trying to find the probability of A complement, we can find the probability of A and just subtract it from 1. Or if we're trying to find the probability of the event A, we can find the probability of its complement and subtract that from 1. So this rule works either one of those 2 ways. Let's look at an example of this. Many individuals age 65 and older rely heavily on prescription drugs. For this group, 82% take prescription drugs regularly. This is according to Money Magazine in September 2001. What's the probability that a randomly selected individual age 65 or older does not take prescription drugs regularly? So if A is the event that a randomly selected individual over 65 does take prescription drugs regularly, then A complement is the event that the individual does not take prescription drugs regularly. Now, we were told in the information up here that 82% of this group does take these drugs regularly. So that means the probability of event A, which would mean a randomly selected individual does take drugs regularly, would be 82%. If we want to find the probability of the complement, all we have to do is take this value and subtract it from 1. So the probability of A complement would be the probability that the randomly selected individual does not take prescription drugs regularly. That would be 1 minus 0.82, and that would be 0.18 or 18%. Here's another example. If we consider the procedure of rolling a die, let event A consist of rolling a 5, find the probability of event A and its complement, and then we're going to let event B consist of rolling a 2 or less, and we're going to find the probability of event B and its complement. So for part A of this, the event A includes just one outcome, and that is that we roll a 5. The complement of A is the event of not rolling a 5. Since our sample space is all 6 faces on the die, that means A complement is every face except for the 5. So it's 1, 2, 3, 4, and 6. The probability of A, since there was only one outcome in event A, is 1/6, and the probability of a complement is 5/6. So we could get this by either noticing how many events were in our A complement, which is 5, or we could just simply take the probability for A and subtract that from 1. Either way, we would get 5/6. Now for part B in this question, the event B consists of rolling a 2 or less. That includes 2 outcomes, because that could either be rolling a 1 or rolling a 2. So B complement would be every other face on the die that's not already included in this set, which would be 3, 4, 5, and 6. The probability of B, since there were 2 simple events in this event, would be 2 or 6, which would simplify to 1/3. The probability of B complement would be 1 minus this, so 1 minus 1/3 would equal 2/3. We could also get that answer by looking at how many simple events are in B complement. There are 4 out of the 6 in the sample space. 4/6 would simplify to 2/3. One more example. This is from the table that comes from the survey. And here we want to find the probability of selecting someone who is not over 65 from the 1,000 survey respondents. So one of the keys to figuring out that you can use a complement is this word not. Not always means that that's the complement of the same event without the not. So if event A is selecting someone who is over 65, then selecting someone not over 65 would be the complement of A. We can find the probability of A by just taking the number of respondents over 65 and dividing by the total number of respondents. So we already have a total for our number that are over 65. That's given to us in the table. That's 315. Our total number of respondents was 1,000. So the probability of A is 0.315. We can use the complement rule to find the probability of A complement by taking this answer and subtracting it from 1. So the probability of A complement is 1 minus 315 over 1,000, or 685 over 1,000, or we could have just taken 1 minus 0.315, and that would give us 0.685.